Good afternoon, ladies and gentlemen. My name is Barbora Svedowa, and I'm junior researcher in our university, and concretely in a center. And together with my colleague, we deal with a lot of research topics as air pollution, street dust, sewage sludge, and the next topic of our research are waste and compost. And today I would like say you some information about this topic, about our research, about our interest. The name of my presentation is The Properties of Compost from Household Food Waste Produced in Automatic Composter and the Environment Risk Compost from Automatic Compost. At first, I would like to say you some definition, some information for introduce. At first, I would like speak about waste. Waste are unwanted or unsuitable materials. Waste is any substance which is discarded after primary use or is worthless, defective, and of no use. Waste products may become byproducts, enjoyed products or resource through an invention that raises waste production value above zero. One part of waste is municipal waste. Municipal waste covered household waste and waste similar in nature and composition to household waste. At first, I would like to show you some graph which deal with waste generated in Europe during 2017. This first graph showed the amount of municipal waste in European Union. For example, in 28 states of European Union produce 486 kilogram per capita. For Czech Republic, it's 344 kilogram per capita. For Poland, it's similar. It's about 315 kilogram of municipal waste per capita. On the next slide, we can see the three pictures. On the left, the green graph, there are information about the amount of municipal waste recycled and composted in the Europe in year 2017. For European Union and 28 states, it's 2025 kilogram per capita. For the Czech Republic, it's 118 kilogram per capita, and for the Poland is a little bit smaller amount. On the right, you can see the red graph. On the red graph, you can see the amount of municipal waste which was incinerated in 2017. For 28 states in European Union, it was 137 kilogram per capita. For Czech Republic, it was about 60 kilogram per capita. And the last graph, orange graph, you can see the amount of municipal waste which was landfilled during 2017 for 28 states of of European Union. It was about 113 kilogram per capita. For Czech Republic, it was about 167 kilograms per capita. We can say that the Czech Republic used very often landfill for destroyed of municipal waste. On this graph, concrete left on the left side, you can see the trend in waste generation during 2004 to 2018, and we can say that in 2018 the municipal waste generation in Czech Republic was about 3.7 million tons. And we can say that the major portion of 56% was the common collection of waste. Waste components collected separately as glass, paper, plastic contributed by 60%, and bulky waste, are carpets, furniture, account for 11%. On the left side, you can see graph which show the municipal waste management from 2018 in Czech Republic, and we can say that about 50% of waste was landfilling, 27% was recycling, 17% was incineration, destroyed by incineration, and only 7% was composting. On the right side, we can see the table with information about amount of municipal waste and way how work with this waste, and the tons of this waste which was used for landfilling, recycling, composting, and so on. And the last graph, on this graph we can see again municipal waste treatment in 2018 for European Union and other states. Again, we can see that in Czech Republic about around 50% of waste are landfilling, about 35% is recycling and composting, and we used only 70% for recovering of energy. Very important question is what will be do with waste in the future. The Ministry of Environment has determined the end of storage of usable and recyclable, sorry, waste for 2030. In 2025, the Czech Republic has the recycling 55% of its municipal waste. At present, the Czech Republic is able to recycle only 38% of the generated municipal waste, and in 2030, the state has to recycle 60% of municipal waste, another 5% over the next 5 years. Very important for Czech Republic is reduction of landfill of biodegradable waste. Concretely, the landfilling is prohibited by legislation. Bio-waste is now a deposit in landfill as part of mixture municipal waste, where this account for about 40% of the landfill waste. The biodegradable waste includes any organic matter in waste which can be broken down into carbon dioxide, water, methane, or simple organic molecules by microorganisms and other living things by composting, aerobic digestion, anaerobic digestion, or similar processes. In waste management, it also includes some inorganic material which can be decomposed by bacteria. During our research, we focus or specify by food waste. We can say that food waste is the waste that is removed from the food supply chain, excluding food used for biochemical processes or as animal feed. Food waste collection and recycling in essential issue in waste management that has gained interest in recent years due to environment impact of food degradation in landfills. The food waste can be classified into the various categories. For example, unavoidable waste arising from food preparation or consumption that is not now and never was suitable for human consumption, as bone, eggshell, tea bags, fruit pits, apple cores, and so on. On average, 55%, 35% of household food waste is avoidable. We can say that food waste alone causes around 10% of greenhouse gases. Concretely, in our research, we deal with household food waste. Household food waste receives considerable attention worldwide due to environment, economical, and social impact it generates. The household food waste can contain contaminants. It can grow regulator for plants, veterinary drugs, and pesticides. The landfilling of household food waste can lead to the releasing of pesticides into the groundwater. The amount of food waste is directly influenced by shopping habits, waste prevention habits, and materialism's value, and etc. And the typical characterization of household food waste are high moisture content, high content of organic components, salts, and low caloric value. It is suitable to handle kitchen waste as organic waste. One way how we can use household food waste is composting. For composting, there are very important five things. Concretely, for composting is very important aeration, particle size and surface area, the content of green and brown materials, moisture, and size of heaps. The composting techniques are used with the aim of decreasing volume and weight of kitchen waste to produce a stable product that can be used for agriculture. The composting on 1 ton of food and meals leftover can generate from 0.5 to 10 kilograms of nitrogen, from 0.5 to 1.9 kilogram of phosphorus, and from 1 to 5.4 kilograms of potassium. Composting can be defined as a process of biological degradation of organic matter that is initiation by decomposition and stabilization of organic substance under controlled thermophilic and aerobic conditions. The compost can be applied as a fertilizer, organic amendment, or growing medium to improve the physical and biological properties of the soil and increase its water retention and carbon storage capacity. We have a lot of composting technologies. For example, vermicomposting. This composting use earthworms for compost, aerobic composting, window composting, in-wells composting, composting using art ponds, or composting using insect. And the selection of technology depends on the amount, kind, and composition of composted materials. The efficiency of composting will be affected by the stability and maturity of the products, Dematurity is a generic term describing the suitability of compost for a particular use, and it's commonly associated with plant growth or phytotoxicity. On the other hand, stability is the term related to the degree of decomposition of biodegradable organic matter contained in a matrix and is indirectly related to the biological activities of sample. The quality of organic matter in compost varies with the nature of composted waste and composting process. The composting of kitchen waste is completely due to the physico-chemical properties of the input substance. The imbalanced nutrients such as carbon and nitrogen, high moisture content, the compact structure may discharge byproducts such as odor or leachate, which can cause secondary environment pollution, especially in countries with high population density. This factor limits the usage of household food waste as monosubstrates in the composting processes. Fast and effective composting of kitchen waste involves the use of automatic composter. The automatic composter makes the batch of the substrate and maintain the temperature and humidity according to the composting phase. Automatic composters are available in many sizes depending on the amount of processed waste. The time for processing kitchen waste in automatic composter range for several hours. For example, for composter food recycle home to several weeks. For example, for composter Jura or Natur Mill. About composter Natur Mill, I will be speak after a few minutes. There is very little information on the quality of compost from household food waste prepared in automatic composter. The process of composting and preparing of compost is very important for for our country because the process composting can save money, can protection biodiversity, it can help build healthy soil, it can preserve our environment or prevent waste and conserve resources. Concretely, in our university, we work with food waste. Our research we can divide to a lot of parts. At first, we deal with food waste from real amount and kind of food waste in Czech families. Concretely, families from our research group collected and recorded the amount and kind of food waste during 1 year. We can say that the vegetable waste averaged 115 gram per person per day. It was in range from 60 to 226 gram per capita per day. The animal waste average 13 grams per capita per day. It was in range from 2 to 29 gram per capita per day. And household food waste have an acidic character. Concretely, pH value was about 4, and these waste have a high conductivity with diameters about around 7.3 millisiemens per centimeter. From the real results, the average composition of household food waste was specified, and this information was used for our future research. Concretely, from this data, we prepare material for preparing compost. Concretely, we must purge and preparation of food, weighting of individual type of food, slicing and chopping food, mixing, slicing food, preparation of package with sliced food. One package have about around 1 kilogram, and then we putting package with this material to composter at the specialized interval. On this picture you can see this food. Concretely we use, for example, banana, apple, pear, potatoes, carrots, pumpkins. We use the bread roll. We use cucumber. We use for example, strawberry and so on. We cut this food and then we prepare this special input to the composter. Concretely, we selected input material for composter once a week, one times. The input material, about 1 kilogram, was fed into the composter every day. The composting processes took about 7 days. And then the young compost was placed on the baking sheet and matured on it for 1 or 3 months, and then this compost was analyzed, was studying, and we use this material for our research. On this picture, you can see the composter, a green good, and we can see the putting of input to the composter. The material is mixed, and the compost is working and prepare compost. Prepare the compost. Yeah. For our research, we use two type of automatic composter. Concretely, we use a composter on the left pictures with name Natural Milk, and the second composter named Green Good. I can say that the composter Green Good is more sophistication. It's more comfortable for you for using than Natural Milk. On this slide, I described the difference between this composter. At first, I would like to speak about Natural Mill. The Natural Mill composter controlled the processes that last approximately 7 days. Optimum is when we input 1 kilogram per week. The temperature during the whole period of composting was maintained from 45 to 55 Celsius degrees. The material was then moved inside the composter to the container for repelling. After the end of this period, it was spread onto the open area for maturation lasting 3 months or more, and the compost from the previous finished test was used as a admixture in other order to enliven to input by bacteria. When we look to the second composter, Green Good composter, this composter used a different procedure where the device controls the process until it is full, and the material is then maintained during 14 to 21 days, and temperature surpassing 70 Celsius degrees. Input is approximately about around 2 kilograms per day. The whole amount of input can be about around 16 or 17 kilogram wet matter with moisture around 65%. For this composter are very important bacteria acidulo. Bacteria acidulo is a nature polyextramophilic organism from the group of Firmicutes. It has a high adaptability for extreme environments, and it's acidophilic. It's mean they can live in pH value from 2 to 5. Bacteria acidulo was added to household food waste in the composter green good, and it is capable of a very productive activity in the environment of a high temperature and the environment with high acidity and salinity. When we focus to acidular composting, we can say that the acidular composting uses a bacteria consortium with the stable dominant of the bacteria Phylum Firmicutes, with a high proportion of the genus Bacillus. Acidular composting represents the thermophilic lactic acid fermentation, and it's used for the processing of food waste. Firmicutes are the dominant bacterial phylum during the composting, and these bacteria have the key importance for the hydrolyzation of polysaccharides and the degradation of lignocelluloses. On this table, you can see the difference between typical garden composter and automatic composters. Concretely, automatic composter nature milk and automatic composter green good. And we can say that the main difference is in the bacteria consortium. Concretely, composting in the nature milk composter is closer to conditions for a garden composter, because these two type of composting use same bacteria, concretely Bacteroidetes, Actinobacteria, Proteobacteria, and Firmicutes. On the other hand, the automatic composter green good using for composting dominant bacteria acidulo, concretely Firmicutes. Then you can see the next or other characterization of a garden composter and automatic composter. For example, during the garden compost, using of garden composter, we can find the odor during the processes. For example, when we used automatic composter green good, this process is without odor. During the using of nature milk, we can't find some odor compounds during the composting, but it isn't typical. For automatic composter is very needed electricity consumption, so this process of composting can be more expensive than using of garden composter. During the garden composter, the temperature influenced by input material. When we use the natural mill composter, the temperature of composting process is around 40 or 50 Celsius degrees for a very long period. When we use a green good composter, the temperature is higher than 55 Celsius degrees. Maximum is around 70 Celsius degrees, and this temperature is very important for hygienization. Um, the time for composting is different for these three type of composter. When we use the garden composter, the time of composting can take from 2 to 3 months. When we use natural mill, it can take only 14 days or maximally 30 days. And when we use the green good composter, the minimal time for composting in 1 day, and the optimum is around 14 days. The difference are also with moisture. For garden composter, it's very important the optimization of moisture. So the same situation is for using of natural mill composter, and for an automatic composter green good, the moisture is not needed. It isn't important factor. Um, I think that there are the main difference between these three types of composter. A very important question is which kind of waste is useful for composting in automatic composter. On the green column, you can see good input to the composter. For example, we can use for preparing of compost fruits, vegetables, meat, kitchen, fish bone, for example, cheese, eggshells, tea leaves, but not back of tea, coffee grounds. We can use wood stove pellets, wood shaving. We can use organic catty litter. We can use pasta, rice, cereals. We can use, for example, corn chips, peanut shell, straw, and so on. But we shouldn't use, for example, some waste with a very strong odor as broccoli, cabbage. We don't use fibrous items as corn husks, lemongrass, hair. We don't use hard items are corn cobs, wine cork, walnut shells, and so on. For this composter, we don't use newspaper, coffee filters, tea bags, or some paper which can be contain unsafe chemicals, or it can cause some odor. For this composter, we don't use a lot of liquid because it can cause mold. We don't use for composting plastic, metal, glasses, bags, cups, rubbers, medicine, cosmetics, soap, and so on. Um, for studying of compost, we can use a lot of devices. For example, in our university, for studying of properties of compost, we can use ion chromatography. Is the separation and quantitative analysis of ions and cations in an ionic solution using the ion exchange method, or liquid chromatography. The chromatographic processes separate the different ions within the sample. Then for studying of compost, we can use the analysis of organic compounds contained in compost and the degree of humidification. For this, we use pyrolysis chromatography. The pyrolysis was carried out at 800 Celsius degrees for 10 seconds with a heating rate of 10 Celsius degrees per millisecond. The interface temperature for pyrolysis chromatography was 280 Celsius degrees, and the pyrolysis unit is directly attached to the chromatograph with an MS detector. Or for studying and determine of element composition of compost, we can use the element analyzer. This analyzer can be used for determination of quantity of carbon, nitrogen, hydrogen, and sulfur by combustion, and the quantity oxygen determination by pyrolysis in all application feeds. For carbon, hydrogen, nitrogen, and sulfur determination, the flash star analyzer operates with the dynamic flash combustion of the samples. When you go to our university, to our center INET, you can see these devices in our laboratory. For compost is very important characterization is ecotoxicity. Ecotoxicity is the potential of biological, chemical, or physical stressors to affect ecosystems. Ecotoxicology is the study of toxic effects caused by nature or from man-made substance on biota. Through ecotoxicology, we are able to determine the levels and types of contaminants that cause harm to animal and plants. And very important for us and for this part of research are pesticides. Pesticides and other contaminants that get into the nature environment can affect wild plants and animals. Very important definitions and processes in environment which are connection with ecotoxicity. Ecotoxicity, there is bioaccumulation. It can occur if residues build up faster than the organism can break them down and increase them. Bioaccumulation in aquatic animals where the pesticide is taken in from the water is called bioconcentration. For a study of ecotoxicity, we use test of ecotoxicity, and for this test we can use special organisms as Daphnia magna, Sinapis alba, or Lactuca sativa, or seed of white mustard, and so on. Very important are pesticides because they are very dangerous for live organisms. The pesticides are essential tools utilized for the pest control. The pesticides play an important role in increasing yield in agriculture by destroying pests and plant diseases. This peer various limitation. 470 kind of different pesticides are using in the European Union. Many pesticides are carcinogenic and phytotoxic, causes disorders of the nerve system and bone marrow, respiration diseases, immunological complication, and infertility. The pesticides occur in input material as well as in the compost from green waste. The composting process can eliminate or concentrated pesticides. It depends on their biodegradability and chemical stability. The mechanism affecting pesticides during composting is biological degradation, extracellular and intracellular decomposition, volatilization, and leaching. The pesticides belonging to the organophosphates groups are biodegradable during the composting and their concentration decreasing with loss of humidity of compost. The occurrence of pesticides in compost represents a significant environment problems because these pesticides can contaminate soil or groundwater. Together with my colleague, we deal with compost, household food waste, and using of automatic composter. And during 3 years, we prepare some articles about this topic, and we present these results to international conference of SDEVES, concretely in Palermo and Dubrovnik. And now I say you some basic information or some results of this research. This research. Um, the first topic deal with evaluate of quality of compost prepared by convention waste biomass composting and composting household plant waste in commercially available composter, concretely natural mill and green good composters. At the beginning, we can say that the study analyzing various waste management scenarios demonstrated that up to 27% of waste could be efficiently composted. The Food and Agriculture Organization of the United Nations reports that food waste represents 280 kilograms per year per capita. It's means 55% of municipal solid waste. Composting techniques are used with the aim of decreasing the volume and weight of kitchen waste. The process produce a stable product that can be used for our agriculture. The composting of kitchen waste is complicated due to the physico-chemical properties of the input substrates. The Green Good Zero Waste concept is recognized by the state authorities of the Czech Republic or Slovakia as an alternative to the statutory obligation to sort food waste and pay for its collection. There is very little information on quality of compost from household food waste preparation in automatic composter. The information on the quality and stability of organic matter is necessary for subsequent use of the substrates. The time of processing kitchen waste in automatic composter range from several hours to several weeks, and it's a very important question and very important part of this research because it can be very fast way how destroy the waste. Sorry. For this research, we use information about food waste from 10 families, which were selected and collected for 20 weeks, concretely from 1st of November in 2017 to 5th May in 2018. For composting, we use two types of composter, the Nature Mill and Green Good composter. To compare the character of the compost was used a compost from Náměšť nad Oslavou. It's a compost which was prepared in a company which specialized to the composting. The compost was characterized by element analysis and proximity analysis. We deal with water-soluble ions by ion chromatography. We deal with organic compounds, and these compounds are studied by pyrolysis chromatography. And the compost from Green Good, number 7, was made only from plant waste, and the compost 8 also contained animal waste. It's very important because on the next slide I will be describe the compost from this compost. On this picture, you can see the raw material used to prepare compost. How I say, the first 7 compost were prepared only from the plant and vegetable. The last 8 compost was prepared also with using of animal food waste. We can see that we can see the total amount of the compost in gram. We can see that for preparing of the first and second compost we use soil, we use soda, sawdust, and then we use the household food waste, but it was only plant. Then you can see that for preparation of compost 3 and 4 we use only soil, household food waste, only vegetable, and we use sawdust. For preparing of compost 5 and 6 we use green vegetation, we use household food waste, and sawdust, and a little bit soda. And the last 2 compost are prepared only from the household food waste. On this picture you can see the composition of plant waste in percent in the delivered state. The key parameter for selection of the technology for disposal of biologically degradable waste is biological stability. During storing of biologically degradable waste, bacterial fermentation take place not only in dairy and meat production, but also in vegetable and fish. These processes involves participate of Enterococcus, whose occurs in compost is limited according to legislation of the Czech Republic. Um, of the Czech Republic. And on this picture, you can see the composition of household food waste. You can see that for composting we use a lot of tuberose plant, vegetable. A lot of compost consists from pastry and pasta. In some compost there are coffee grain, tea, flowers, and the last compost 8 was preparing with adding of animal waste. On this slide and pictures, you can see amount of plant and animal waste produced within household food waste and household food waste composition. We can say that the vegetable was around 29 weight percent, tuberose plant was 28 weight percent, and fruits predominantly peel was around 16%. The coffee ground are around 8 weight percent. The highest variability plant waste is shown by pastry, pasta, and rice, on average around 16 weight percent. On this picture, you can see amount of household food waste concretely plant and animal per person per day. On this picture, you can see again amount of waste, concretely fruit, vegetable, pastry, flour, and coffee, tea, and during our research, we studied water receipt. We can say the compost from the natural composter differ from compost from the green good composter in the pH value, conductivity, and the content of sodium, which are affected by the addition of soda to the batch. On the other hand, the content of potassium, total phosphorus, ammonium, nitrogen, and dissolved organic carbon in compost from the green good composter show higher concentration in the aqueous extract. The conductivity value do not meet the limits in any of the compost even after 4 weeks of maturing. The value of dissolved organic carbon was in range from 40 to 60 gram per kilogram after the completion of the natural milk composter processes, and after amount of maturation they drop by about ratio 1 to 3. The same drop in dissolved organic carbon by about ratio 1 to 3 after amounts of maturation is also shown by green good composter compost. The conductivity value is influenced by the high concentration content of dissolved organic carbon, which was confirmed by a statistically significant dependence, and the correlation coefficient determined was 0.74. The characterization of a household food waste compost, unlike compost from biodegradable municipal waste, are a higher content of fluorides, sodium, potassium, and phosphorus, which are easily infusible. And in addition, for compost from natural meal, the high volume of electroconductivity is affected by the addition of soda. The critical parameter for compost stability stability assessment is dissolved organic carbon, which identify the transformation processes and also maturity. And we can say that increased amount of sodium in compost applied in soil cause its rapid intake by plants, increased sodium intake, reduce potassium, calcium and magnesite intake. Evaluation sodium contents in compost are only advantageous for natural fossil plants such as bedroof or spinach. Sorry. On this table, we can see the results of approximately and ultimate analysis of compost, concretely for 7 compost and compost náměšť. We can say the compost prepared from kitchen waste contain a very acceptable amount of nitrogen, phosphorus and potassium. The amount released into the aqueous leachate of compost was from 0.3 to 0.8% of total nitrogen. And the difference became evident in the nitrate content in aqueous leached from compost produced in a natural mill composter, which is higher than the average content in compost from green good composter. The higher alkalinity caused by the addition of soda to the batch of the natural milk composter influence both cell synthesis and nitrification. The decrease in total nitrogen concentration in aqueous leach with compost maturing time is minimal. On this slide, you can see the results about organic substance in compost, and the compost prepared in automatic kitchen waste composter are characterized by high level of undergrade hemicellulose and cellulose. The lowest amount of undergraded cellulose and other polysaccharides is in compost with name key 1. The amount of the concentration of compounds derived from lignite, cellulose, hemicellulose, stretch, saccharides, wax, fats, proteins you can see on this picture, and we can say that the amount of organic compounds derived from the degradation of polysaccharides as cellulose, hemicellulose, starch, and saccharides in the kitchen waste compost is from 2.88 to 75.9 microgram per milligram. The amount of polysaccharides and saccharides in compost is affected by the composition of the feedstock. The average volume of organic compounds derived from degradation of polysaccharides and carbohydrates is 1.5 times higher in compost prepared by household food waste composting than the value achieved by composting using green waste or municipal waste window composting technology. Compost 1 contain predominantly 56% of tuberose plant and 34% of pastries. The compost 3 contain predominantly 44% of vegetable, 22% of tuberose plant and 26% of fruits. And the starch contained in compost 1 is likely to decompose faster than the vegetable during composting. The content of aromatic compounds in compost prepared from household food waste show that the amount of humic acid and the degree of humidification of compost is significantly lower than of green waste compost prepared by window composting. For all compost prepared from household food waste, with the exception of compost 7, the amount of cellulose prevails over hemicellulose. The abundance of aromatic pyrolysis products in individual composts prepared from household food waste is from 9 to 16%, and the average was around 12%. For comparison, the content in Namieść was 25%. The content of lignin derived compounds in compost perlites range from 1 to 18 micrograms per milligrams, and for comparison, in commercial compost it was 13 micrograms per milligrams. The organic compounds derived from the degradation of lignin, concretely alkyl phenol, could be an indicator of the evolution, transformation, and stabilization of organic matter. The higher content of alkyl phenol was in commercial compost Namieść. The compost from household food waste contain alkyl phenol only in amount from 61 nanogram per milligram to 840 nanogram per milligram. The amount of alkyl phenols in household food waste is significantly lower than in compost prepared from green waste in commercial company. The amount of degraded hemicellulose and cellulose in compost can be expressed using the ratio of hydroxypropane to furan methanol concentration. The ratio of hydroxypropane to furan methanol concentration decreases with the degradation of the substrate. For all composts prepared from household food waste, with the exception of compost 7, the amount of cellulose prevails over hemicellulose, and the hemicellulose is preferentially degraded before cellulose. After 8 weeks from the end of the composting process, the compost have decreased concentration of organic compounds derived from the hemicellulose and partially cellulose. The increase of humidification coefficient after 8 weeks from the end of the composting processes was significant. In comparison, the previous compost analysis, some substrates have up to 10 times increased humidification coefficient. The compost Namieść has only negligible change of the humidification coefficient. From this part of research, we can say that the amount of household food waste in typical Czech families was around 100 kilogram per capita per year. The compost prepared in natural mill and green good composter prepared from household food waste do not meet the requirements of electric conductivity required by legislation due to high infusible dissolved organic carbon. The parameters of compost maturity are not met even for the ratio of ammonium nitrogen to nitrogen nitrates. The compost from natural mill and green good compost differ in the pH value, ammonium ion leaching, which has been affected by the addition of soda in natural mill composter. The compost from green waste and municipal waste prepared by the window composting technology contain more stable humic substance, and they have a higher humidity index value. The mineralization of organic matter take place in this compost more efficiently than in compost from household food waste prepared in automatic composter. The usability of compost from household food waste prepared in automatic composter for horticulture and agriculture application is greatly limited by unproper properties, low stabilization, and humidification of organic matter, which is manifested by the low content of heterocyclic nitrogen form and alkene phenols. The characteristic feather of household food waste compost prepared in automatic composter are the low content of organic compounds derived from proteins, amino acid and peptides, and high content of polysaccharides derived compounds. With respect to change in organic matter content, the compost prepared in automatic composter cannot be considered unstable after the completion of composting. The second article which we prepare on this topic and we represent in international conference Davos was named the potential environment risk of the utilization of compost from household food waste. At first, I say some introduction for this topic. The efficiency was not just study for composting of household food waste with the content of pollutants, concretely pesticides, in commercially available automatic home composter from the point of their decomposition. Like information about physical and chemical properties as pH value, conductivity, leachable of ammonium or anions and cations of compost truss obtained, as well as their stability for the safe agriculture or horticulture application. At the same time, concentrations are not known for toxic organic compounds which can enter the environment and contaminate the food chain after application of composts. The main aim of this part of research was draw attention to the problematic parameters of compost from commercially available home automatic composter and to identify risk properties of compost with possibilities of their minimalization. For this part of our research, we use again two types of composter, concretely natural mill and green good composter. I describe this composter after 20 minutes maybe, so I am not dealing with this. I describe some methods for studying of compost yet, so I only say that for this part of research we used again ion chromatography, pyrolysis chromatography, and we use thermal decomposition of samples using thermo analyzer Mettler Toledo, and we use tests of toxicity and ecotoxicity. Um, On this pictures, you can see the input composition of raw material for the preparation of compost. Concretely, for this research, we use 8 compost from natural milk and 3 compost from green good composter. We can see that the dominant for composting were household food waste. For preparing of compost 5 in natural milk, we use green waste. For compost 1 and 2, we use the soil, and for preparing of compost in green good composter, we used only household food waste. The detail of composition of household food waste you can see on the right picture. We can see that this waste was consists from vegetable, tuberous plants, fruits, pastry and pasta, coffee, tea, flowers, and animal waste. For our research, we used again household food waste, which was collected and separation in typical Czech families during whole year. And we use this waste for preparing of compost in natural milk and green good, and we can say that the householder were divided according to the elemental inhabitants. The first group A had prevailing vegetable in the food, and the second group B had a prevalence of tuberous products as potatoes, pasta, rice, and pastries. And the percentage of spent coffee ground varied from 6 to 10%. The percentage of household food waste of group A and group B you can see on the left picture, and on the right picture you can see the average a composition of input to the natural mill and green good composter. We can see that the composition was similar. Different was only in animal waste. This animal waste was input only to the green good composter. Um, when we see to the results on the table, you can see the physical and chemical properties of leached from compost and calculated the deviation. We study, how I say, 9 compost from natural mill and 3 compost from green good composter. We can say that the average content of sodium in natural mill was 21 gram per kilogram, and for chloride it was 3 gram per kilogram. For this compost we added the soda. The second group are the compost from natural mill, where we add sawdust, and the average content of sodium was 5 gram per kilogram, and chloride was 7 gram per kilogram, and the average content of sodium in green good composter was 3.5 gram per kilogram, and for chloride it was 6 gram per kilogram. The compost from natural milk contain higher concentration of sodium and chloride, increasing salinity of compost. The increased concentration of sodium and chloride in the composts are caused by the presence of pastries and leftovers of boiled food as potato, pasta, and rice, and by the addition of soda. Um, the difference in pH value and conductivity between compost from both composter are caused by the addition of soda in the composter natural. The low pH value of compost is given by the input composition of raw material contained in household food waste. The value of ratio carbon to nitrogen do not meet criteria for stability of maturity for all compost prepared in the automatic composter, natural mill and green good. The recommended range of ratio carbon to nitrogen for the stability of maturity of compost is smaller 14. When we look to compost from natural mill, we can say the average pH value was around 7.6, and value of electroconductivity was around 8.9 millisiemens per centimeter. On the other hand, the average volume of pH from green good was around 4.6, and value of electroconductivity was 5.5 microsiemens per centimeter. The value of carbon and nitrogen ration for compost from green good was from 21 to 23, and the volume of this ratio from compost from natural mill was from 25 to 68. Uh, 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 68. Add mixtures of sodas and soil to household food waste. It causes increasing of this ratio in composts. The compost from green good contain carbon that is better reachable. Its name dissolved organic carbon, and nitrogen with worse reachability. The concentration of the nitrogen in the compost 7, 8, and 9, the presence of animal waste in the input material for composting. The content or percentage of leachable and non-leachable nitrogen and carbon you can see on this picture, on the picture on the right side. Nitrogen is orange and carbon is green. The different character of processes in both composters is also apart from the value of oxidable carbon, which is lower for the compost from green good composter, and confirms that the processes of hydrolysis prevail over oxidation processes in the composter natural mill. Um, a very important factor of compost is content of a pesticide. Compost contain mostly insecticide, acaricide, and herbicides. All compost prepared from household food waste mainly contain pesticides used primarily for the treatment of wheat, rice, and potatoes. In the compost, 3 herbicides and 5 insecticides from the following group were identified. For example, it was organophosphates, carbamates, trizines, parathiroids, diphenytrals, and diphenytrals. The concentration of pesticides which were determined in compost from natural mill and green good you can see on the picture on on the right, and on the picture here you can see avoided and prohibited pesticides and their or the concentration of these pesticides in of eight compost from natural milk and from the green room composter. We can say that we find prohibited prohibited pesticide in commercial compost from Namnest. Also, it can be caused because the pesticide can accumulate in environment for a long time. Um, the amount of pesticides in household food waste compost varies from 8 microgram per kilogram to 45 microgram per kilogram. Compost for urban green material has 5 times lower pesticide content than the household food waste compost. The compost from green good composter have significantly lower contents, bixenos and primicart compared to natural composter. Um the preparation times of compost in the green good device is longer than 21 days, whereas the natural milk compost it is only 7 days. Another important fact is the difference in temperature or bacterial consortium in this two type of composter. On this picture, you can see the concentration of pesticides in each compost from natural milk green good and from a company in city Namnest. The highest concentration of carbophenol was found in the compost 5 and 6. The content and representation of pesticides in household food waste compost prepared in the natural mill and green good depends on the composition of the feedstock, its treatment with pesticides, and the efficiency of composting. One of other toxic and persistent pesticides contained in compost prepared from household food waste, but also from urban green matter was bifenthrin. The differences in the concentration between natural mill and green good was found for the pesticide carbophenonitrile. The household food waste compost contain about 4 times more bifenthrin than compost prepared from urban green matter. Carbamate pesticide in household food waste compost are the lowest of all observed pesticides group. Very important in compost are humic acid also. Humic acid can significantly reduce the migration of pollutants by sorption processes. The origin of humic acid is also influenced by pH value. Optimal pH value for input into compost is considered to be pH from 6 to 8. The compost from the composter natural mill have pH value in range from 6.6 to 7.5. Compost from green good composter have pH value substantially lower, around 4 from 4 to 5. Statistically significant correlation relationship was found between concentration of pesticide and humic acid in composts. This depends in significantly higher for permitted pesticides, which confirmed the possibility that these pesticides are bound to humic acid, while pesticides from the prohibited group do not form the statistically significant relationship. Concentration of humic acid in the compost from household wood waste vary in the range from 4 to 7%. They are lower in comparison with data for compost from the literature. The concentration of humic acid in natural milk and green good you can see on this box plot. The last important thing about compost from natural milk and green good is ecotoxicity. The ecotoxicity of the compost from household food waste prepared in the composter natural milk and green good was studied at organism Poecilla reticulata, Daphnia magna, Desmodesmus subspicates, and Sinapis alba. The leach from the compost 7-8 had a concentration of 3 gram per liter dissolved organic carbon, and after washing 4 times the lychee had still a concentration of 140 milligrams per liter, which can be the probably reason of 100% immobilization of Daphnia magna. The possible separation of compost ecotoxicity was also tested by addition of biochar, 5, 10, and 50% certified according to the European Biochar Foundation, and production in Austria. The addition of biochar had no influence on lethal ecotoxicity, mortality, inhibition, and immobilization for all testing organisms were 100%. Addition of peat for concretely 40% and bentonite concretely 20% to the compost from household food waste was tested also, and inhibition of Sinapis alba also in this case was 65% for natural milk compost 7 and 8, and even 100% for green good composter and compost 3. Finally, we can say that in the green good included partial decomposition of present modern pesticide in comparison with the compost from natural milk. The decomposition of traditional pesticide is limited, and the increased decomposition of pesticides in the green good is influenced by the length of the composting processes, because it's take more than 21 days. The compost formed in the automatic composter from household food waste have a high volume of electroconductivity. It's due to presence of salts. Electroconductivity influences the ecotoxicity of the compost. The concentration of approximately 1% of salt in the compost causes the inhibition of Sinapis alba, concretely 26%. So the removal of salt by washing with ratio of 1 to 1 can ensure that inhibition will be smaller than 30%. On the other hand, washing with the ratio of 1 to 3 will result in the inhibition smaller than 5%. Direct utilization of the compost from household food waste for horticulture, gardening, and agriculture is possible after the suppression of electroconductivity by removal of salt using washing in the ratio 1 to 3. Finally, I can say that in our research center we have some project which deal with preparing of compost, composting, using biochar to change properties of compost, and so on. And in this project, we deal with this topic. We study the composting process and preparing of compost, and we would like prepare better and more better compost for using in common life. And the last slide, I would like to say that the issue of composting is very, very important and is gaining more and more attention. The use of biodegradable waste is suitable for optimizing the soil environment. The use of biodegradable waste for the production of compost is a suitable way of disposing of waste and minimizing its disposal in landfill. And the use of household food waste for the production of compost is very complex and brings with its wide range of problems and ambiguities. So very thank you very much for your attention. I'm so sorry for my pronunciation. It's true that I deal with composting with my research group, but it isn't my main topic. My main topic is air pollution, combustion processes, and composting isn't my main topic. So sorry for my pronunciation, and if you have any question, I would like I should and I can answer to you with my research group, and have a nice day, and thank you very much for your attention.